Hi, I'm Rajesh Kasirangan, one of the co-founders of ClimateX, and we have our first speaker here, who is Gabi Marks, a PhD candidate in the Department of Earth and Planetary Sciences at MIT. Welcome, Gabi.
Thank you. I'm excited to be here.
Yeah, it's great to have you. Tell us a little bit about yourself.
Sure. I'm a second-year grad student, as you said, and I study paleoclimate, paleoceanography. I'm in the joint program with MIT and the Woods Hole Oceanographic Institution. So I travel back and forth between the campuses, and I'm advised jointly by faculty at both MIT and Woods Hole. So I have sort of an oceanographic view on climate and geology. So.
Oh, that's fantastic. So tell us a little bit about your research.
Yeah, I study paleoclimate, and so I work with stalagmites from the Yucatan Peninsula in Mexico. And what we're doing is, well, we go and collect them, and then we are analyzing different elements in them to understand how much rainfall there was in the past. So my lab works mostly on dating them. So we figure out the x-axis part of it. And then we have collaborators who help us with the y-axis. So we mostly look at oxygen and carbon isotopes to, like I said, look at how much precipitation has changed.
Wow, that's fantastic. So is that very technically demanding work?
It's a little tricky to do the drilling. It's very small scale because the pieces will be about this big or so, and then there might be multiple pieces, or it might just be one that's about this big. And we're drilling at about 1 millimeter resolution, so sometimes smaller than that. So we end up doing a lot of squinting down at the samples, but it's a lot of fun. We get to do a combination of collections and drilling and wet chemistry and then analysis. So it's cool to see the whole process.
So are you climbing up walls, or is it mostly?
We're climbing down. We climb into caves, and we're using the stalagmites, so the ones that grow from the bottom of the floor of the cave up to however tall they grow. So we go in and we try to take ones that are fallen down as much as we can, because these are really precious and we don't want to take more than we need to. So whenever possible, we take stalagmites that have already collapsed. Sometimes they naturally collapse. Sometimes people have gone into the caves and knocked them down. So we take the samples and then we bring them back here, and we have to slice them in half. And then drill them and go through that whole process. But when we get them, we have no idea what they're going to look like until we bring them back to the lab. So it's a little exciting.
Yeah.
It usually works out.
Huh. So tell us why you chose this particular direction.
Yeah, I started, my undergrad was at Bowdoin College in Earth and Oceanographic Science. And I loved really the combination of Earth and oceanography. That's why I chose my major, and that's why I am where I am now. I love looking at how land and water interact and how that changes climate, how climate has changed those interactions. I think that looking at the whole Earth as a system is really interesting. And I started out with a project on bamboo corals as an undergrad. So I was doing similar things where we were using chemistry techniques on the bamboo corals, which are small branching ones. They sort of look like tiny trees underwater. And we were analyzing those to look at chemistry changes in the water. So it's sort of a similar application of research, just on a different material now. And I like it because I think it's really fascinating to think about changes in climate on a lot of different time scales. So my favorite time scale is probably from about 0 or a couple thousand years before the present to now, and looking at how different the world that we live in now is from then, and how different the cycles are. When you look at a museum and you see like these are the dinosaurs, what I'm more interested in is, wow, there's tons of ferns and it looks really tropical, and like, where were these dinosaurs? Why is it so tropical in this place that now is really cold, and how did that happen?
Cool. So humans have probably been changing the climate for a pretty long time, right?
Yeah.
So tell us a little bit about that. Like, have we been the bad guys forever, or is it a recent thing?
Yeah, I think that's still a topic that's under discussion or up for discussion, still being researched, because some people say, the concept of the Anthropocene. So some people say that we didn't really start changing climate until about 1850, right? The beginning of the industrial age. But other people say that if you look back at the first human civilizations, you can see that there were changes in climate. So if you look back really early on, people first started deforestation. That had a big change. That made a big change. People were saving water and directing water. So my research is mostly where the Mayans lived, and they had these ways to store water that we don't even fully understand now. But I think that humans have been changing the environment that they live in for as long as humans have been here. And the question is, how long have we been as damaging as we currently are? And I don't know the answer to that question. I think it's also interesting to think about how climate has impacted humans. So, for example, have there been collapses in societies because climate was so unstable? That's something that I like to look at in the Yucatan. There's other examples in Cambodia. There's examples of maybe warming, somehow changing climate in the Andes with the Incas. And so I think that study, they call it sometimes empire and climate. I think that's fascinating. So I don't have all the answers, but I think that it's been a long time coming, and now it's just gotten to the scale where humans are changing the earth and climate at a rate that we've never seen before.
It makes me think that there are possibilities for entirely new disciplines that are not just science and not just humanities, right? Because is it history or is it climatology?
Right, they have history of science, they have anthropology, and I think we need to all work together a little bit more. I don't have the anthropology background or the archaeology background to really understand Mayan civilization the way I would like to, but sometimes archaeologists and anthropologists don't have that same climate science background. So I think working together is going to be really important in the coming years, decades, as we go into research more.
Great. So talking about research and coming back to the present, tell us a little bit about where we are with climate science today.
Sure. I think that a lot of times scientists end up thinking about funding and about data. I think those are sort of two big things, and often they're connected, right? So we always want more data. We always want more to think about and more to understand better. That's what at the core, I think science is trying to understand as much as you can about whatever your area is. Some people, they want to study worms, and that's not for me, but I really want to learn more about climate and understand that system. So I think that the future is in large part about big data and using as much data as we can get as efficiently as we can to try to understand climate change, in part because climate both is changing and impacting the whole world. And so it's not something that I think we often have to think about as like this huge scale change. So it's not just, one test tube of water. It's not just a current even that's moving all the way up the East Coast. It's even bigger than that. So thinking about how we can combine all the small sets of data that we have, like I just have one stalagmite, so I'm not going to pretend like that's telling us everything about the whole world, but I can combine that with other records from across the world and really create a detailed record of what has happened globally. I can't do that, but scientists as a whole can do that. So I think that that's where sort of the future is. And I think people are starting to collaborate more and see that. And there's the open access movement. There's the, trying to put data into repositories. They're really great repositories with NOAA, and those are the ones I'm familiar with. But I think that kind of movement toward sharing data and being really willing to collaborate has been, it's really nice to see, and I think it still has a little bit further to go.
That's fantastic. And can you think of like a challenge that, let's say, if you had, infinite amounts of data and infinite amount of money, right? But what would be a challenge that you would like to address if those constraints were removed?
Yeah, I think first you have to think about what data you're looking at, right? So if you could, one question is how can we use big data to assess the impact that climate change has already had? So we still have political problems where there are people who don't necessarily want to do something about climate right now. So how can we show that already we've had this impact from climate change in the modern era? So from say 1850 to the present, 1900 to the present, whatever you want to cut it off at. How can we use that big data to show what has already happened? And then I think going forward from that is improved modeling. So I would like to see really great models that show storm surge or how much wind is going to happen. We've had floods here in the US, we've had droughts here in the US, and it's been really devastating, and it causes a lot of damage both to property and to, it changes people's lives. They're going home in Louisiana and their homes are flooded for months until they can get it all cleaned out. So I would love to see improved models so that we can better understand both where and how those big devastating events will happen. We can't prevent them. Well, at this point we can't prevent them, but I think having a better understanding will help to both save property and lives.
Right, and I can also imagine that we would have much better risk assessment too.
Yep.
Where do you build houses?
Mm-hmm.
So.
Yeah, and where can you put money in to improve infrastructure, build better bridges, build safer infrastructure overall?
Yeah,
I think that's a really nice, that's a challenge for people, right? Is to think about where the next problems are coming up on whatever scale it is. So if it's in your personal, your town, in your house even, if it's in the whole world, whatever scale you want to look at is where you think the next big challenge is, I guess, within climate change.
Great. So moving from huge challenges to tiny ones, because we're going to be running an unhangout session. And is there something that you would like to at least provoke our audience? Something that says, here's something to think about during the unhangout breakout sessions and after the session is over to chew on.
So the next section is going to be on citizen science and doing your own kind of scientific inquiry, I guess. And so my session, I think, would be really interesting if we talk about what data do you know that you could collect or that your friends, your family could collect that could contribute to a better understanding. So not, if I had $1 million, here's what I would do. But as I am right now, one idea I had was, could you take a picture of the clouds and say, these are what the clouds are looking like today? And if you had 100 people in your city, that would be more data than we had before, right? So what can you as one person do to add to that pile of data, and what would the impact of that be?
Wow. Actually, I have a question for you. And I don't know, which is, has climate change changed the actual shape of is there a visual marker, say, in the clouds of climate change? Like if I look up every day and I note it, will I see a difference?
I don't think you would see a shape change, but I think, and I hope I'm getting this right, I think that it would be interesting to see if we had increased cloud cover, increased precipitation, rain, snow, whatever is coming out of the clouds in certain areas. So it'd be more of a comparison across time, I think. That's a good question. I mean, here, even in Massachusetts, we have a drought right now, and it's not nearly as bad as the one in California, but we do still have a drought. And I think we could look back at the summer of rainfall and we'd have a lot less than we expected. But it'd be interesting also to think about not just the rainfall, but clouds, right? So how much sun could make it through to really baking the soil. And that's just one example of how that could work. But I don't think you would see a shape change in the clouds, but I have some friends I could ask about that.
There you go.
Yeah. Collaboration, right?
Yeah, exactly. Great. I think that this has been really, really useful. One last question before we let you go, and we'll see you on the day of the Unhangout, which is, what would you like, if there's something for our audience to read or to watch before they come join us? Do Do you have any suggestions?
There's a podcast right now that's being produced called Our Warm Regards. And I think it was like a iTunes editor's pick of the week or something, but it's put together by a couple of climate scientists, and they discuss current issues in climate. And I think that'd be a great place to start, especially if you took the MIT edX course. I think it'd be a great little, yes, it would be a great little refresher to think about current issues in climate change, and maybe it would give you some ideas about what data you would want to collect and what you're most interested in learning about throughout the course of this ClimateX experiment.
Great. Thank you so much, Gabi. This was great, and we'll find out maybe soon, maybe never, whether the shape of clouds or not.
I'll try to get an answer for that.
Yeah. But in the meantime, I hope that your collection, your stalagmites tell you exactly what you want them to tell you.
We'll see.
And we'll see you in a few weeks.
Thank you.
Bye.